welcome to the stage Alex Byaly.
Hello, welcome to my talk. It's about causal graphs. So this is sort of a technical talk about solving a technical problem. And it's a problem that is subtle from one point of view, even though it can be really obvious from another one. So the first thing I'm going to do is I'm going to recreate the problem, generate some data live, and then I'm going to show how to see it, so that if you have a thing you're working on and you see the problem and someone else doesn't, and you want to convince them that it exists, you'll be armed for it. I'll look a little bit at some things other games do that cause the problem to go away. I'll talk about causal graphs, what they are, what they're used for. They're not used for this. This is a repurposing. So we'll see them in their natural form. Then we'll do the repurposing. So I'll walk through it. First, a little bit about me. I've been doing 7 DRLs for about 5 years now. Only the most recent 3 have been successful, but I feel pretty good about them. These are web games. You can play them all in your browser. They're on itch, so go check them out. So let's get into it. So first thing, we're going to generate a data set. So I'm going to be generating population data for a fantasy world. So I'm going to be generating attributes for characters. So every character will live in some city, one of Agraria, Cliffside, or Megalopolis. Oh no, it was not supposed to be showing the title bar, but all right. Okay, there we go. Oops. Okay, so every person will have a species, bird, goat, or mole rat. Everyone will have a favorite food. Everyone will have a job. And finally, every person in this world will be involved in some form of crime. So the method I'm going to be using for generating them is for each of these traits. What I'll do is I'll take a raffle. So I'll put some number of copies of each of these things into a hat, and then I'll draw from the hat. So for city, for example, I'll take 1 copy of Agraria, 3 copies of Cliffside, 6 copies of Megalopolis. And when I do this, I'll draw Agraria much less often, Megalopolis much more often. So most people in this world will live in the big city. So for every one of these traits, I'll have some other weights, some other number of tickets, and we'll get some data. So this is, I guess, a top zoomed out summary of everyone I've generated so far in this world. So the numbers are going up. It's being generated live here. And from this perspective, this problem is completely invisible, so it's impossible to see it right now. But what I can do is I can zoom in on a subset of the population. So what I can do is I can filter this. So what if I look at the breakdown for only people who live in Agraria? Let me undo that. And it looks like nothing has changed, but if you look closely, you can see that the numbers have gotten smaller. And the fact that the proportions haven't changed, you can actually see them move a tiny bit if you're looking super closely. But that's actually the problem I'm getting at here. So no matter how much I restrict the population I'm looking at, the proportions of everything I'm not filtering on stay exactly the same. So this data is perfectly symmetrical. And I claim that's bad. So if you think about things that you can investigate in the real world, so for example, let's say you're surveying people, you walk into a restaurant and you start asking people, what's your favorite music? And depending on which restaurant you go to, you'll get different answers depending on what time of day you go surveying, you'll get different answers. And, different cities, you'll get different distributions of answers. So these things, there's no particular good reason for those things to be interconnected, right? Like, what does a restaurant have to do with style of music? On the face of it, these should be totally unrelated. But there are just these random fun coincidences all over the place in the real world, and that's part of what makes exploring interesting and fun. So when you travel to go to a new city, people will act differently. There will be different things to see, and that is exactly missing from what I've made here. So this is a thing where once you've gone and explored Agraria, and you met all the people there, and you learn, okay, there's 1/3 of them are goats, 1/3 of them are birds. This many have jobs as painters. This many are involved in copyright infringements. You go to a different city. You go to Megalopolis, and it's exactly the same. There's no difference. What was the point of going to a different city? So this is, I think, one face of the oatmeal problem, where you have some 200 some possibilities, but there's no particular reason to pay attention to any of them. So let's look at some solutions. So this is a randomly generated item from the game Tales of Magial. And the way this game generates its items is these different traits on the item, these show up in batches. So of clarity here, you see the Titan's Copper Ring of Clarity. So this is part of a package deal. So clarity comes with mental save, it comes with confusion immunity, and this is why this ring is infused with psionic forces. Another package deal is a copper ring. It's a tier 1 item. So tier 1 items have smaller stats than tier 3 items, which are made of a different material. There's a Titan's ring. So this comes with constitution, physical save, and being infused by nature. And finally, this is a ring, and this tells you how much it weighs, tells you to use ring egos. So different items in this game. So Titans and of Clarity, these are both egos, and different items have different egos available. So there's a specific list of egos that are available for rings. So if you rolled a pair of shoes, it might have different egos available, and this also adds to some of the character you see. And finally, this ring makes your fingers look great, which you would not find on a pair of shoes, I assume. I don't actually know all of the items in the game, so maybe I'm not ruling it out. And so what this making traits show up in batches does for us is this picture from before wouldn't happen. So if I was looking at which things have mental save, we would see that more of them have confusion immunity. If I was looking at which things have confusion immunity, more of those would have mental save than just the general pool of items. And this kind of texture has consequences on build planning. So if you know that these two stats tend to show up together, and you have a plan like, oh, I really want to have 100 confusion immunity, then that's a reason that maybe it's okay to skimp on mental save because you expect those stats to show up together. Another game that does not exhibit this problem is Dwarf Fortress. So there's two different things going on in this game. Well, more than two, but two I'm going to talk about. One of them is this use of real-world models. So there's a erosion, and there's a biome system, and a bunch of others. And what the use of real-world models does with regard to this is that anything in the real world has these patterns to it, and people who are trying to make predictions and model these patterns, well, if you reproduce that model, you're going to end up with patterns in the stuff you generated, and that you don't get this perfect symmetry if there's basically any pattern in there. So that causes this to go away. Another thing that Dwarf Fortress does is during the history generation, there's a strategy game that plays out, and some things cause you to be better at the strategy game. Well, not you, but the AI. Some actors end up better at the strategy game. Some actors end up worse. 5 minutes. I thought this was a 30-minute talk.
Yes, it is. I think that's just scheduling confusion on our end. Sorry, Alex.
Oh, okay. Okay, so because there is a simulation being played out there, some of the things end up better at the simulation, some of the things end up worse at the simulation, and based on the rules, the final results also end up with patterns to them, even if, as the starting point, there weren't any. So let's talk about causal graphs. So this is a picture of a causal graph. Very simple one, just two things. So a causal graph it is made up of things and arrows between them. And the arrows represent cause and effect relationships. So this causal graph says that there's a cause and effect relationship between forest fires and ice cream sales. This doesn't tell you the specific direction of the cause. So maybe forest fires make ice cream sales go up. Maybe forest fires make ice cream sales go down. But you know, in this there's some relationship. And the way these are typically used, you would take a causal graph and you would also collect some data, and you would mix them together, sprinkle in some math, and that would get you a model that you could use to make predictions. So the model that you'd get from this graph would, of course, say that forest fires increase ice cream sales. So if there are less forest fires, then ice cream sales would necessarily go down. So if there is a new firefighting technique invented, and you think that forest fires are going to be half as frequent going forward, then you could put that into your model and you could get a prediction on how ice cream sales will be affected. So that is how much they'll go down. And this is a useful prediction, right? So you can tell all your friends who run ice cream businesses, hey, maybe this isn't the best time to buy a house, or maybe you should consider getting out of the ice cream business entirely. Of course, someone else can come up with their own causal graph, so you can draw cause and effect relationships whichever way you like. There are no rules to this. And if they take their other graph and mix it with the same data, then they'll end up with a model that makes different predictions from yours. And at that point, I'm not sure exactly how people settle this. Maybe it's like I know that at least there's a lot of fighting on Twitter, and maybe the occasional fist fight or pistols at dawn or something. I'm not a scientist, so I'm missing part of the picture. But the important thing is that lots of different graphs fit together just fine with the same data. And this is rough for the scientists, but it's actually really good for me, because what the scientists are doing, they're trying to go backwards. So they take the graph and they take the data and they try to reason out, like, okay, what model could I have what model predicts this? And the direction I'm going from graph, use the graph, make a model, use the model, make the data. And the fact that lots of graphs correspond to the same data, for me, that means that I don't need to worry too much about what kind of graph I draw. I could draw the arrows in whatever combination, in whatever direction, and I'll still probably be able to get similar kinds of data, even if they were drawn differently. So let's do it. So first step, I'm going to make a causal relationship between city and crime. So this is the graph. And the way it's going to translate to actually generating this is I'm going to do the raffle for the city before I do the raffle for the crime. And then, based on the city I get, I'm going to add or remove raffle tickets for the various crimes. So if I draw Cliffside, I'm going to add raffle tickets for slander and tax evasion. If I draw Megalopolis for the city, I'm going to take out slander tickets, I'm going to take out tax evasion, I'm going to add copyright infringement. If I draw Agraria, I'm going to add slander and take out the other ones. So let's see the effect of this. So let's reset the clock on that. So again, in the top level view here, none of this is visible, right? So we can't see what's going on unless we actually zoom in. So let me zoom in and show you. So let's look at Megalopolis. So the only crime being committed in Megalopolis almost exclusively is copyright infringement, so not much of the other ones. In Cliffside, there is more tax evasion than in general, but the other ones still show up. And in Agraria, we have a lot more slander. So this follows the chart. Now, so the arrow from before, this affected the order I drew them in, and this is the ostensible cause and effect here. But we still get a relationship in the other direction. So I can click on these, and I will see changes in the city. So if I look at copyright infringement, I see a bit more of it comes from Megalopolis, but it's still well represented in the other ones. If I look at slander, it looks like it's almost a 50-50 split between Cliffside and Agraria. And if I look at tax evasion, it looks like this almost entirely comes from Cliffside. And this backwards relationship was a emergent consequence of what happened before. I didn't have to do anything. This just came along for free. So let's add some other arrows. So let's add an arrow going from city to food. Let's add an arrow going from city to job and from job to crime. And let's add arrows going from species to all of these. And when I actually generate, when I generate these, I need to do the raffles in an order that makes me never go backwards on an arrow. So if I do a raffle for food, I can't, how this arrow doesn't let me do species after that. So I can do an order of species, then city, then food, then job, then crime. So if I do that, then I never go backwards along any of these arrows. And generating it in this way does put some restrictions on how I can put these arrows down. So I can't make any loops in the arrows. So I can't, going forward, if I go species to city and city to food, food to species, I go backwards along an arrow instead of forwards. And I think there's a way to make adjustments here. So instead of doing a single raffle, you could go through it a couple times. And if you do that, then you could have backwards arrows, and that would work out. But I didn't in this demo. And then let's make some numbers for all of these arrows. So the meaning here is basically the same as it was before. So in this chart, I had rows and columns. So the columns corresponded to what I drew first. The rows correspond to what I drew next. So here, for species, so the three species correspond to the three columns. And once I know which species I have, this tells me how many raffle tickets to add or subtract from the different cities. All right. So now we're doing this according to the new scheme. And the first thing that stands out to me here is that Agraria is almost entirely underpopulated. So, and this is a kind of quirk that comes from this sort of thing. But what I could do is, if that's not enough, I could go back and change the base number of raffle tickets that Agraria gets, or I could adjust some of the grids so that Agraria shows up more. And if I zoom in here and see what type of people live in Agraria, I see that Agraria is entirely populated by goats, and they eat almost exclusively grass and the occasional mouse. And this is I think this is fun because the city is now quite different from Cliffside, where mice are a much more popular food. And these labels for these different things, these sound like they should have some obvious connections to them. Like accountants, well, do accountants do more tax evasion or less tax evasion than everyone else? And we can answer that question. And in this world, they do a bit more. And we can come up with a story that explains that, right? So, it makes sense for accountants to be better at tax evasion. And this could have gone either way. I could have clicked on this and it could have been less. And then we could say that accountants have more respect for their taxes. And every relationship that we see here, there's room to explain it somehow, right? So mice are a really unpopular food for goats. Why is that? I don't know. That is, if I don't come up with an explanation for that, if I put this in a game, players can come up with an explanation for that. But there's still something worth explaining. So this is storytelling fuel. Also, no one in Agraria eats mice. Oh, right, yeah, they only eat grass. This is also a source of stereotypes, right? So basically, there are very few goat mouse eaters, but there still are some, right? So the few goats that do eat mice, so these are bucking the trends, and they exist. So if you just assume that nobody who eats mice is a goat, then you will be occasionally surprised. And this is a type of surprise that you would never see if you had never made that assumption in the first place, if there was no pattern there at all. Thank you for your attention. And are there any questions?
Excellent. All right. Thank you. Yeah, I mean, it's great. Mostly there's a lot of discussion about whether or not goats could catch and eat mice. To be honest, that's the current trend. But yeah, so people in chat, please use the write a question button to ask some questions since we got some time here. Yeah, I mean, I think maybe just to kick it off while people add some questions, there was some discussion in the chat about the need to balance like having enough patterns to make predictions and then having kind of the breaking of those patterns to have the surprise, which I think you were kind of touching on the end there. Is there maybe a philosophy you have to finding that sweet spot?
I have never used this in anger, so I still don't know what problems I'm going to run into and how I'm going to have to solve them.
Yeah, that's fair. So actually, and there is a question of whether or not there is sample code available for this.
So it is not in a state where it is publishable, but I could clean it up and share something.
Okay, cool. That would be great. Because it seemed fun to play with. Yeah. People keep going with it. I guess I'm also curious, like, what are some of the directions that you want to keep developing in it? Like, what's some of the stuff that, you think could be next steps of wanting to go even deeper?
So when you're creating these type of patterns kind of randomly, this creates a disconnect because you can't carry things you learn from run to run, and you can't carry things you learn from player to player. So one of the things I'm thinking about is once I've generated this kind of relationship, to hold it fixed for a period of time, or across runs or like a week or something, so that people can learn it, they can talk about it, they can plan around it, and then have a new version later.
Right. Cool. More questions coming in now. So one interesting one, what's with the negative numbers when changing the amount of raffle tickets? As opposed to it being 0, that kind of like -4 to tax evasion.
That's taking raffle tickets out.
Okay.
So if there were, by default, 4, and I take 6 out, then now there are -2, but I treat that as 0.
Right. I see. So balancing out whatever the default values are. Cool. There's also a question of just how much you might have been inspired by, or if you see the connection. Someone, Travis, was saying that the framing of kind of creating interesting populations reminded him of Annals of the Peregrines by Emily Short.
I am not familiar with it.
Okay. Well, it is interesting because it is a similar thing about populations and kind of cities, which I think is cool. There was another book. Hey, Kawa, you over there? You remember? What's that book about generating cities? And you read it about cities.
Oh.
Kawa also doesn't remember. People
sorry.
in chat, if you remember, there's a book about visiting different kind of procedurally generated-ish cities. It's very cool. Yeah.